Hey, what is good, everybody? Welcome back to the video. So in the previous video we set up our physical device. So in today's video we are going to set up a logical device. So let's get to it. So back in our vulkan.c, I've just basically opened up this function and I just basically return true by default. And in the renderer.c, I just basically duplicated this guy and then just basically changed the naming to the logical device. And I've also just passed it the physical device and also the logical device that we're storing. And if you don't have this yet, just go to your context definition in your Vulkan context and just add the VK device and name it logical device. And then from there, you should be up to date with where I am currently at. I just did this off camera, but yeah, it's nothing too major. So let's start ahead and let's basically figure out how to select a logical device. So if you look at the tutorial, you'll notice that this page is fairly small, right? There's fairly not too much to really do here. In fact, there's really isn't much, right? But unfortunately, this is really not all of it really, because this is still tied off to surface creation, so you're still gonna basically have to come back to this function and add to it. So it will definitely get longer than what you are currently seeing. So without wasting any time, let us get straight to it. So the first thing that I want to do in terms of the logical device selection, I essentially just want to deal with the features that I'm going to support. Okay, so what I'm going to do is I'm going to start with querying for, let me think about it first. Let me see, what do I need to do first? Features, yes. So I'm going to have to start querying for the features that we want. But then how do I want to do it? Because all right, let's do they have extensions? Yeah, they do, but they're not setting it. Okay, so we're gonna need to have extensions, device extensions. So I think that's what I'll start with. But there is one special feature that we have on the Mac, and that is the portability extension requirement. So we're gonna query for that first and just handle it. I don't know if it's totally Mac specific, but let's just query for that and see if it indeed is required, right? If that extension is indeed required. So let's query for portability extension, right? And see if it's required, because I'm not sure if it's a Mac thing, but yeah, I'm on Mac, so I know about it, but I don't know if you actually do need it on other operating systems, because I don't have any other operating system. So I'm gonna have a boolean here, and then I'm gonna call this portability extension required. Now this is required on Mac by default, but I'm just doing it this way just so that you guys can see how to basically query for the support and see if you really do need it for your logical device as well. So I'm going to do U32, and then I'm going to do available extension. Let's do count, extension count, and I'm going to set that one to 0. Then we're going to query. Okay, so this will be, well, the extension, the portability extension will be in the extensions we're going to query for. So let's just quickly query for those, right? So let's do VK enumerate device extension. So it's going to be inside these extension properties. So let's do that, and then let's pass in physical device. They want my physical device, so that would be my GPU. And then they're gonna want the layer name. I'm just gonna pass in 0 there. They're gonna want the property count to basically, oh yeah, that will be our available extension count. That's what they're going to populate. And then essentially we are going to store that somewhere. So where am I going to store that? Well, for now, we actually don't need to pass in anything because we don't have the list yet. So we're just enumerating for the count. So once we have the count, we can then create the list. So I'm going to do an if statement here, and then we're going to check if the count is actually greater than 0, right? So if it's basically not equals to 0, let's just do greater. So if it's greater than 0, then we know we have a list of extensions. Okay, then because now we do know that we have a number of extensions, all we can then do is create a list to store those extensions in. So I'm going to do vk extension properties, and then I'm going to create a list to store that in, and I'm going to call that available extensions. So I could say available device extensions. In fact, let's do it this way, then it's more explicit. Available device extensions. You don't have to name it explicitly, but yeah, it's just for me to know. And I'm going to need an array, so let's include our container array. So let's do containers, and then let's find the array. There we go. And then once we have the array, we can do array create. Now I could actually, you know what, let's do a reserve, because I now know the list, how big the list should be. So I could just create a list that contains the exact amount that I need to reserve space on my system. So let's do vk extension properties, and then that will be device count, available extension count. Yeah, and then that should create the array for us. And then after, we can then call this function again, right? So let's just call this here, but this time around we pass in the list so that we can populate it. Okay, so we're going to pass it in there at the end. And then we need to update our list because Vulkan directly bypasses all our functions to add items to the list and just basically modifies that memory for us. So we just need to update it so that our array knows that hey, we literally do have this amount of items now, so fix yourself. Okay, and to do that, we simply just call array set count to the new count. In this scenario, it's this guy here. We're just doing this so that we don't have some nasty stuff going on later on. And the list that we want to update the count for is the device extensions list. Yeah, and that's it. Okay. You could argue that I don't really have to call this because it is the exact size, but I actually do for safety. Yeah, I don't want surprises. So after that, all I need to do is int I equals to 0, and then I is less than available extension count. We need to basically iterate. So I'm gonna iterate through the list. Yeah, I just can't see my keyboard. I'm actually coding in the dark, by the way, but I can't see my keyboard for whatever reason. But it's because my mic is in front of me. And yeah, all right. So we have the for loop, and then we need to iterate through each extension. And through each extension, we need to get the name of that extension, and then we need to see if it matches the VK portability subset extension. And if it does, then we do know that, you know, we are going to basically need to add it to the device extensions list because we're on Mac and portability extension is kind of required. So we might have to add that to our device extensions list that we are going to create. So yeah. So how do I want to check this? We can do an if statement, and I think I'll need an include. Actually, it's from the standard library, so let's do string like so. and then down here I can just do string compare, string cmp, string compare. Then we're going to compare the two names. So I'm going to start off with the available extensions, and then I'm going to take the current index that we add. Oops. Wow. Yeah, like that. Then we're going to get the extension name, and then we're going to compare that with vk. Let me just type it, vk. I could be typing this wrong, but it's going to be vk khr portability portability. I think it was subset, yeah, like this. And then if this is true, if we found it, all we want to do is just debug, print something for ourselves. And then all I'm going to do is say adding required device extension. In this case it's this. I'm just going to copy this like so. Okay, so like this. What am I doing? And then I'm gonna basically say portability extension required equals to true. Okay, we're gonna use this to then actually add that to the required device extensions list. So outside of this loop, then we're still inside another loop. So, but wait a minute. Yeah, so outside of this big loop, okay, I then need to essentially check if indeed it's supported or not. So the way I'm going to do that is I'm going to do if portability extension is required, then I'm going to add that to a list. But we don't have the list, so we need to create it. To do that, I'm just going to do a const char, and then this will be our device extensions list names. Yeah, let's go with names. So yeah, it will store the names, and I'm just gonna give it 6. Okay, yeah, I'm just gonna give it 6 because I don't know, I think I might have done this before in my previous engine, and I noticed that it was not exceeding 6, so I just gave it 6. Yeah, but I could be wrong about that, but I'm gonna stick with 6 because that's what I'm used to. And then I'm gonna do device extension names. Okay, add 0, and then we're just going to then add this. Okay, so to test if, well, not that first, because that we're adding in here. So what we want to add is this. Do I want to do that now? Swap chain, because we do need the swap chain. Do they do it now? Well, they don't really care here at this level, but they will definitely check for that somewhere in here, I think. No, possibly in here then. Yeah, here we go. So I'm gonna take this. You see how they have the device extension? We have ours here now, right? So to that, they added the KHR swap chain extension name, which I'm just gonna copy and put it in here. So notice how we jumped all the way to the swap chain stuff. That's because they're all related, right? Everything from the logical device all the way here somehow cross each other, and then you have to come back to the logical device creation to add support for that stuff. So I'm gonna do it all of that in this video so that I don't have to do it later on once we get to the swap chain creation and all the other stuff. Okay, so yeah, so I'm gonna add this. Then indeed, I think I might have to keep a counter. I don't know, let's see. I don't know, let's just see. So I'm gonna add device extension names, and then I'm gonna do one here, and then this should be this guy, portability subset. Actually, let me take this one. Okay, like so. And then I'm gonna close this off like this, and then all I'm gonna do is I'm gonna get my device features, which they are doing, I think, in here in the logical device creation features. Yeah, but we're gonna make use of features too, because we need support for dynamic rendering and all the other cool stuff, right? So I'm gonna do vk physical device features. I'm gonna do 2, then I'm gonna do device features, features like this, equals to an empty struct. Okay, so then I'm gonna do device features dot s type, and this will be vk structure type, vk structure type device create info. No, that's the wrong one. They don't give us that. Yeah, that's the wrong one, but I think what we're looking for is vk structure type physical device features 2 khr. Yeah, this one. Okay, and in here we're going to basically enable some features that we want to support. So we're going to do device features dot sampler and isotrophy, and that is going to equals to the physical device dot features dot sampler and isotrophy. Okay, like so. Nice. So I'm gonna do features dot the other one that I want is fill mode non-solid, and then I'm gonna do physical device dot features dot fill mode, like so. All right, and then the other feature that I want is device features dot shader clip distance, and that should be physical device dot features dot shader clip distance, and that should be fine. Okay, and then down here all I'm going to do is if not device features dot shader clip distance, then I'm just going to do an L. I don't know if I want it to be an error message, but I'm going to do shader clip distance, because it shouldn't really crash if it's not supported, but I don't know. So let's do shader clip distance not supported by Vulkan device. Okay, and then I'm gonna do dash this. Okay, and then you don't have to print out the device name, but I'm just gonna do it for fun. So the physical device properties dot device name. So see how and why I actually stored those properties, just so we can easily access them and don't have to basically query for them each time we want to make use of them. So yeah, it's just good to cache things sometimes, you feel. But yeah, and then once we get to this level, I think that's it, right? Once we get to that level, then we can basically continue to basically add new stuff to this, right? And for now, what I want to do is, I said we're going to support dynamic rendering. So to do that, I essentially need to do, let's do physical device dynamic rendering. Let's say dynamic rendering features. Yeah, this one. So then I'm going to do dynamic rendering. Rendering dynamic. Ooh, my spelling is bad today. Dynamic rendering. extension, then this should just be equals to 0 destruct. So let's do dynamic rendering extension dot s type, and then this should then be a vk structure. So vk structure of type physical device, and I think the one I'm looking for is dynamic rendering. I don't know which one it is. Dynamic rendering features. Yeah, I think this is the one. Okay, yeah. Okay, so now what I then need to do is just say dynamic rendering extension dot dynamic rendering funny enough, is equals to vk true, because we're enabling it, right? So vk true, because we want to make use of dynamic rendering. And if you're still confused what I mean by dynamic rendering, is the normal way the tutorial is working or is showing you how to set up Vulkan is the old way, where you basically made use of render passes and frame buffers. So in dynamic rendering, we don't need to set up frame buffers and render passes, I believe, right? So it just makes things a little bit easier for us. But you'll see as we go forward, okay? Don't need to think too much about that for now. Then I'm gonna do dynamic rendering dot p next. Now this is very important because it kind of caught me off guard on my previous implementations of Vulkan. But essentially what you need to pass in here is just this. Okay, if you're not wondering where this is coming from, it's just this. So you're literally just calling itself, okay? And then I think the next thing I need to do is, because we said we've added this, so now we're gonna have to take this, okay, and then instead of one, now let's go to the second one, and then from there I'm going to add the dynamic rendering situationship stuff, right? So let's do vk khr dynamic rendering extension name. Okay, so we're gonna add the extension name to the extension list for our device extensions. Okay, and then once we have that, we can then move on. And then what I'm gonna do is I guess I can do vk device create info, so, and then I can do device create info is equals to an empty struct. Then I can do device create info dot s type is equals to device create info. Yeah, this is the one I want. Oh, I copied more than I needed. So like so. Okay. And then once I have that, all I need to do is device create info, device create info dot pq create infos, and we've hit a roadblock. Well, it's not really a roadblock, but I'm gonna get back to this part. So I'm gonna comment it because I actually do need to set that up, which I haven't. And then I think it's gonna have a brother who is called where is it? Enabled. Is it extension count? No, it's not. It's, I think it's Q. No, I don't know. Oh, Q infos. Then the count, right? So I'm also gonna come back to this. I'm just putting it in there so I do not forget about that. And then I think now I can do the device count, extension count. So let's do device create info dot enabled extension count should be, how many extensions do we have? We have 1, 2, 3. So we have 1, 2, 3. So I'm gonna set this to 3. I could make it dynamic, but actually fix me. Make dynamic before I actually forget about this. Dynamic. And then that's when we can do device extension. No, device create info dot pp extension. Which one was it again? pp extension count, pp enabled extension names. So it's this one. And then we have to do device extension names, which is the array that encapsulates all these 3 extension layers that we've basically added to the list. So it's 1, 2, and 3. Okay. And then I think after that we should have a p next. So device create info dot p next, and this will point back to at device features. And device features, if you're still curious, it's what we set up here. So you notice how it's essentially just adding the features that we want, clip distance and all of that stuff, and then we just basically calling it down here. And then that's about it, hopefully, right? That's about it for now. Yeah, so what I'm gonna do is down here I'm gonna do vk create device. Is it like this? Yeah. Then we're gonna pass in the physical device, so luckily that is stored in here. So physical device GPU, then we're gonna need the create info, so that will be the device create info. Allocator, we don't have one, and the device is what we basically going to store it at. We're passing it in here when we call this function, so it's just logical device. So we can just say logical device. Okay, and if all of this is not equals to vk success, then I just want to throw like a nice little basic error message. Okay, and then we can do error and be like failed to create logical device, and then we return false. And then down here, if we basically, you know, got through, we can just do all info. Then we can just do I guess we can do logical device created, right? Yeah, logical device created, something like that. It's just, yeah, it's just for me to see that indeed it got created, right? I think this might not work because I still need this and a few other things, but I chose not to do it, and I think I might not do it in this video. So let me cross my fingers and hope that this will actually work. Compiled successfully, and 1, 2, 3. Let's see what happened. We have an error. So q create info count must be greater than 0. Yes, I say that I actually do need to set that up, and I didn't, but I did put comments, right? This is what is referring to, the q create info and the q create info count. I need these, but I haven't set them yet. But I will set them, and I think I might just do that in the second video. Kind of feeling a little bit tired right now, but if you look closely, you'll notice that Vulkan layer, or the debug messenger, is telling us that it has inserted the following layer, VK Chronos validation, and then it has also basically added 3 extension counts, 3 extensions, which are KHR dynamic rendering, KHR portability subset, and then KHR swap chain. And if you're wondering where those three are coming from, notice that we said we are basically activating 3 extensions, and those extensions are the dynamic rendering, which you see down here, over here, and then the other one is the VK portability subset, which you see over here, and then you see the swap chain, which is the first one we added to the list. So those are the 3 extensions that it enabled, and then finally it then created the logical device. And I believe if I close this, it should complain, telling me that I did not destroy the device, and yes, it does. It says VK device has not been destroyed, which I can simply do by going to the Vulkan renderer, and where we're shutting down, I can just do VK destroy device, and then we just pass in the device, and that's stored in the context. So we just do logical device, and then the allocator, we don't have any, so we don't need that, so we just build again. And then when I run this, okay, and I close this, we shouldn't get any error, and it still should say Vulkan debugger shut down successfully, and that's it. It works. So we essentially created our logical device. However, we're still not done in that function, but I chose, whilst I was basically coding this, that there's a little bit more that's going to go in this function, but I don't want to overwhelm you guys and make you think that you actually kind of need a lot of these things, which you don't need them right off the bat just yet. But this is just about what you might just need to create your logical device. So in the next video, we'll create our family queues, our present queue, graphics queue, and all of that stuff, and then we're gonna basically enable them when we create our logical device. I think I'll see what happens after that. Yeah, so if you guys enjoyed this video, I'll see you guys in the next one. Take care, and cheers.